Good evening, sir.
Yeah, good evening, Dhare. Yeah, good evening, Dhare. Just give 2 minutes till everyone join. Okay, so in the last class there, I had sent one of the assignment in which we were doing the questions from light chapter. Today we'll do the questions from chapter Human Eye and Colorful World. Okay, let's continue.
Good evening, sir.
Yeah, good evening, Subhash. No, from the same assignment, we are going to do Human Eye. Okay, and after the class, I'll be sending another assignment. Okay, good evening, everyone. So, see, what are the concepts for the human eye and the colorful world? We have the concepts regarding the frequencies, dispersion. Okay, so let's start. These are the questions from human eye and the colorful world. So, color of sky appears blue due to which of the phenomena?
Atmospheric refraction.
No, it's not atmospheric refraction.
Scattering
It
of
is,
light.
yes. Which phenomena is responsible?
Scattering of light.
Yeah, scattering of light is responsible for color of sky to be blue. So the sky appears blue in color due to scattering of light. Color of sun appears white during the daytime because
All colors of white light is scattered away.
All colors of white light scattered away. No.
Sir, but
So color of sun appears white. It is due to, see, blue color scatter the most. Obviously, blue color scatters the most. But why does the sun appears white? See, white color is scattered the least, but white is actually it is a combination of all the seven colors. So which of the options will you go with? It will be certainly option D only. Let's see question 3. Red color is used as a danger sign. As Swanch,
Sir, it scatters the least, so it is more visible than the other colors.
okay, red color is scattered least by smoke. Okay, phenomena on which human eye is working.
Sir, reflection.
This one, phenomena on which human eye is working. Again, I think if you can't answer this, so there is a simple phenomena.
B.
No, not reflection. See, in human eye, it's like this. You have a eye lens and light comes from outside. It gets refracted and the image is formed on the retina. So which phenomena is responsible?
Refraction.
Refraction, right? So here the correct answer is refraction of light. Then which color of light refracts most when passes through a prism?
Good evening, sir.
Which color of light refracts most when passes through a prism? Which one?
Sir, indigo.
Indigo. Out of the, since violet is the one, but here violet is not in the option. So the next option is indigo. Okay, so we'll go with indigo.
Sir, I
Then
joined a bit
which
late.
of the
sir.
following controls the amount of light entering the eye?
Iris.
pupil.
Pupil. It's the pupil that controls the amount of light entering the eye. Iris controls the pupil. Yeah, Aryan, what happened?
Sir, I joined a bit late, sir. What were you doing, sir?
We are solving the assignment from Human Eye and Colorful World.
Okay, sir.
Okay. Then which type of image is formed on the retina of human eye?
Sir, real and inverted.
Yeah, real and inverted. Since our lens, eye lens is a convex lens, so it forms real and inverted image on the retina. The change of focal length of eye lens is caused by the action of?
Ciliary muscles.
Yes, it is the ciliary muscles which cause the change of the focal length of eye. See, our eye lens is made up of a protein. Okay. So a contractile protein is there. That protein can expand and contract, and hence the shape of the eye lens can be changed. It is done with the help of the ciliary muscles. So ciliary muscles, they apply a force from the sides. Okay. So they apply a force on the eye lens to compress it or to elongate it, and hence change the focal length. The human eye can focus objects at different distances by adjusting the focal length of the eye. This is due to
Accommodation.
yeah, it is accommodation. We also call it power of accommodation or accommodation. The least distance for distinct vision is
25 centimeters.
yeah, it's
25
25
centimeters.
centimeter. Option C, 25 centimeter. Okay, now assertion and region. Answer these questions. So both, of course, you are aware of all the options. See, question 11. A beam of white light gives a spectrum on passing through a prism. Okay, so is the assertion correct? Is the assertion correct or not?
Yes, sir.
Yes, assertion is true. Okay, so we have assertion is true, and the region speed of light outside the prism is different from the speed of light inside the prism. Is the region correct? Don't relate with assertion. Just
Yes, sir.
think.
It is correct.
Yeah, it is correct. Speed of light outside the prism is different from the speed of light inside the prism. So it is correct. And now you correlate this. So now you correlate assertion and region. That is region and explanation of the assertion. Is this the reason why there is dispersion of light or why there is a spectrum formation?
No, sir.
So what is the reason behind it?
Sir, because different wavelengths of lights have different refractive index, so they
Yes.
disperse differently.
Yes, yes. So that is the reason. Different colors of light have different speeds in glass. You can also say different colors of light, they have different refractive index. So hence there will be dispersion. So region is correct, assertion is correct, but region is not the correct explanation. So it's option B. Got it, everyone? See, generally when you are getting option A and B, it is quite confusing. So here it is option B. See option 12, question 12. Myopia is called farsightedness. Is it correct?
No, sir.
Sir.
No. So which option will be correct now?
D part.
Yeah, then your option D is correct. Right. However, these options 4, all the options, they are the same in your board exams also. But just you need to go through them that whether they haven't changed. However, if board makes any changes or amendments, the board informs. But if there is any change, you must go through the paper carefully. Assertion. By using Tyndall effect, we can identify the colloidal solutions. Yes, is it true?
Yes, sir.
Yes, sir.
Yes. In true solution, the path of light is not visible. Is the reason true?
Yes, sir.
Okay. And is it the same reason that because of which we can identify the colloidal solutions?
Yes, sir.
Yes. So assertion and region both are correct, and region is the correct explanation of the assertion. Okay, and then question 14. Atmospheric refraction is responsible for advanced sunrise and delayed sunset.
Yes, sir.
Yes.
Yes, sir.
So atmospheric refraction is the responsible phenomena behind advanced sunrise and delayed sunset. Reason? This is happening due to the temperature difference between the layers of air.
No, sir.
No. So why does it happen?
Sir, because of difference in
Because of the difference in
optical density.
uh, okay, first of all, see, is the region correct? Do the layers of air have temperature difference? Do the layers of air have temperature difference? Yes, the layers of air, they have temperature difference, and this is not the reason why there is advanced sunrise and delayed sunset. Even if they all the layers of air they are at the same temperature, then also you will observe advanced sunrise and delayed sunset. Okay, so okay, I'm also writing the options here. I didn't write the option. So for 12, myopia is called farsightedness. This is false, so this was option number D. By Tyndall effect, okay, so this was option number A. For 14, atmospheric refraction is responsible for advanced sunrise and delayed sunset. This is true, and the region is not true. So which option will be there? This will be option C. Now assertion: cataract can be corrected by using bifocal lens.
No, sir.
No. So now it's option D, right? Assertion is incorrect. So you can go with option D. Okay, now here a case-based question, case study-based question is there. When a ray of light incident on a prism, it will split in 7 colors. That is called dispersion of light. A prism is transparent refracting body bounded by plane faces which are inclined to each other at a particular angle. Okay, so have you gone through this? Now you can go with question 16. Okay, read question 16. For which color the angle of deviation is minimum? Yeah,
Sir,
Sumansh.
red.
Okay, for red color, the angle of deviation is minimum. Very good. So you are to, if you see the bending is maximum for violet color. Okay, minimum for the red color. So you will say that yes, you can observe this. The deviation is minimum for the red color. So the answer is red. 17. When a white light falls on a prism, the ray of its surface suffers.
All of the above.
Yeah, it suffers all of the above. It suffers refraction, it suffers dispersion, deviation, so it suffers all of the above. That is option D. In nature, dispersion of light is happening in
Formation of rainbow.
formation of rainbow. Very good. The cause of dispersion of light is
All the colors of light do not travel with same speed.
okay. All the colors of light speed more than the speed of light. All the colors have different angle of deviation. All the colors of light do not travel with same speed. All the colors have same wavelength. So which of them are correct?
Sir, C.
C, C.
What about B? Is B not correct? All colors have different angle of deviation.
No, sir.
It is also correct. Different colors have different angles of deviation. Okay, so the correct reason here is option C. It is due to the option C that option B occurs. So we'll go with option C. All colors of light do not travel with same speed. The following diagram, the path of ray of light passing through a glass prism is shown below. So here the path of the ray of light is shown. In the diagram, the angle of incidence, the angle of emergence, and the angle of deviation respectively are. So have a closer look at it. I hope now it's visible to everyone. Okay. So which one you have to identify the angle of incidence? Which one is the angle of incidence?
Sir, X.
No. See, angle of incidence is the angle found between the incident ray and the
Sir,
normal.
Y.
Y.
Yeah, so it is y. Then angle of emergence.
Q.
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 So y q, and then the angle of deviation.
P.
Sir, P. YQP.
P.
Yeah.
P. P.
So y q p. The correct option is D. Got it? Okay. And what is meant by power of accommodation of eye? I think you can see. Okay, just solve this question 22. A person with myopic eye. All of you solve this and tell the answer. A person with myopic eye cannot see objects beyond 1.2 meter distinctly. What should be the type of the corrective lens used to restore the proper vision? So you have to tell the type and power also. What should be the type and what should be the power?
Sir, type is concave lens.
Yeah, it is a concave lens. And what should be its power?
Sir, 1 second, sir. Sir, 0.83 diopter.
Okay, so just let me check. Answer, it's 1 divided by. Yeah, the answer is negative 0.83. Okay, is there anyone who finds out difficulty in solving such a question? So is there anyone who can't find the solution to this question 22? Finding out the power of the lens when the near point or the far point is given. See, even if you don't tell, I just go on with this question, explain this question to all of you. Some of you may be able to answer it directly. Okay, still we go with this. Yes. Objects beyond 1.2 meter distinctly. What should be the type of the corrective lens? So first of all, think of the myopia. How does myopia occur? So for the myopia to occur, in the case of myopia, a person is unable to see far off objects. Right? So just think of this. Actually, the solution is very small, but you need to understand the complete situation here. So during myopia, we observe that image is formed of a far off object. The image is formed before the retina. When the person tries to observe the far off objects, he can't observe the region being okay. It's something like this. So this happens, and the image is formed somewhere before the retina. Now to obtain, he is now able to see only objects up to the distance of 1.2 meter. The person can see only up to the distances 1.2 meter, beyond which he cannot see. So to restore his normal vision, for the normal vision, the object distance has to be infinite. He should be able to see the objects placed at infinite, and currently he is able to see the objects only up to 1.2 meter. So there should be he should be using a lens, so that the lens should be able to form the objects of infinity. Their images should be formed at a distance of 1.2 meter. Are you getting? So the image of the objects which are far off, their image should be formed at 1.2. So we have here image distance V has to be negative 1.2 meter. Since if the person uses here a lens, so the lens should be able to form the image here at 1.2 meter, up to 1.2 meter, so that the person will be able to see it. Got it? So we got it 1 by F equals 1 by V plus 1 by V minus 1 by U. If you put 1 by U, that becomes 0. So 1 by F equal 1 by V minus of 1 by infinite. So 1 by infinite is 0. You always get 1 by V equals to 1 by F. Hence, V is equal to F. Got it? So V here is negative 1.2 meter, which is equal to F. Got it? So for the myopia, you can consider whatever is the person's, if the person is not able to see the images at a certain place, so obviously his focal the lens that he should be using, it should have a power of 1 by V. Got it? Let's see the next one. What is the far point and near point of human eye with a normal vision? So with the normal vision, what is the far point?
Infinity.
Infinity. Very good. And the near point?
25 meters, 20 centimeters.
Near point is 25 centimeter. Then a student has difficulty reading the blackboard while sitting in the last row. What would be the defect the child is suffering from?
Myopia, sir.
Myopia. Obviously, the child is suffering from myopia. Okay, which is nearsightedness. And how can it be corrected? So it can be corrected by using a concave lens.
Concave lens.
Then see question number 26. What happens to the image distance in the human eye when we decrease the distance of an object from the eye? Think of it and then answer. All of you, I can ask now anyone. So what happens to the image distance in the eye when we decrease the distance of an object from the eye?
Sir, increase or decrease?
What happens?
Sir, increase or decrease, sir?
Okay, so in the human eye, where is the image formed?
At retina.
At retina. So every time the image is formed on retina, whether the object is far or the object is near, where is the image formed? It's always formed on the retina. Yes or no?
Yes, sir.
Yes, so the image is always formed on the retina. Try to understand this concept of this question is related to the concept of accommodation. See what happens with the human eye. Okay. Light on camera. Light on camera. Okay, so for the see, wherever you place the object, I take here two cases. Whether you take the object near or whether you take the object far, every time your image is formed on the retina, right? Is this correct? So if your eye is observing something which is close, so still the image is formed on the retina. This is the image distance. Okay. Then even when the object is very far off, so then also the image is formed on the retina. So still you have your image distance as the same. Again, this is your image distance. Okay. Since the curvature of the eyeball is not changing every time, what can you say about the image distance now? Aryan,
Yes, sir.
what can we say about the image distance? Does it increase or decrease? Or does it remain the same?
Sir, decrease.
No one is having answer. Dharya? See here, the image distance remains the same. The image distance does not change. Okay? Is it clear to everyone? Image distance is constant. For our eye, the image distance V is constant. It doesn't change. Okay? Whereas U is changing. So U is changing, V is constant, right? So in the formula, 1 by F equals to 1 by V minus 1 by U. So see now, this factor is constant. I can represent this to be a constant. So this will be 1 by F equals to some constant K minus 1 by U. Now, what do you think if you are changing U? So what should happen now? Focal length will change. For the formula to hold, if the image distance is changing, so the focal length will change.
Yes, sir.
Yes or no? Sudhanshu, is this correct? Huh? Yes, Sudhanshu, is it correct? Sudhanshu, Ayonija, Ayonija, are you there?
Yes, sir.
Okay, so understood this?
Yes, sir.
Okay, so image distance is constant, and hence if the object distance changes, so the focal length needs to change, and that is why our eye lens shows accommodation. That is why accommodation is required. If the image distance was a variable, so why would we require to change the focal length? Got it? So this is the reason. Since image distance is constant, always the image has to be found on the retina. So image distance is constant. That is why we must have change the focal length. Got it? So that is why our eye shows accommodation. And I hope everyone has understood this question. Okay, so see, the image distance remains the same. Now answer this question. Why do stars twinkle? Why do stars twinkle? Now again, all of you have become irresponsive. You're not responsive. You're not responding. Siddharth,
Sir, because the starlight passes through many layers of Earth's atmosphere, and
then
each
answer.
time it
Think it and then answer. Okay, and no one, Siddharth, can you answer? Yeah, Siddharth, can you answer this?
Sir, because uh, light passes through our atmosphere, and the starlight
Okay.
passes through our atmosphere and is bent and distorted by uh, many densities of air. So
See, when the light travels through multiple layers of the atmosphere, it suffers refractions. Okay, so due to the changing density of the atmosphere, sometimes a large amount of light enters our eyes and sometimes a small amount. As a result, the stars appear to twinkle or they appear to flicker. So I will expect all of you to just go through this answer once everyone is there. So all of you just go through this answer and then explain. Why do stars twinkle? These two questions, they are the typical questions of this chapter. Why do stars twinkle and why planets don't twinkle? Okay, so I hope everyone has gone through the answer. Okay, draw the sketch diagram. I think you can do sketch of the human eyes required. Okay, this question, how can we see objects? So this basically explains the complete working of the human eye. I think you haven't done any questions of this type. So try to do this question also. How can we see objects? So I want a written answer from all of you. Just go through, write this question. How can we see objects? So this question is homework. I want to see the answer for this. How can we see objects? Hypermetropia, myopia is always okay. So it's all we have done. Okay. So by all of you, I think we have done all of these questions. So with this, we finished the questions of the chapter Human Eye and Colorful World. So maybe I will be sending one more assignment of this topic. Try to complete that all. Okay. Bye all of you. See you again in next class. Thank you and happy learning.
yes, sir.
Okay.
Bye.